So what we're going to learn today is how to make a linear drumming sequencer in Max for Live. A linear drumming sequence is a sequence where at one head at one time on one beat only one drum head is hit. So it'll look something like this. As you see, in each 16 note beat, there's only one drum head that's being played. It sounds something like this. Cool. So this is the one that I've already built, but we're going to learn how to build this. So we're going to bring up a drum track and pull in a Max for Live MIDI effect on that. You can find the Max for Live MIDI effects in the Max for Live tab, and under the Max for Live MIDI effect, just drop the Max MIDI effect. Now what this is like a basic framework on how to build your Max for Live devices, and you can open up the editor for it by clicking on this button. So there you go. It brings us to the Max for Live editor, and this is like a basic framework. So you have your MIDI in and your MIDI out. So since we're going to build our own, we're going to delete this, and we're going to bring in an itable. So we do that by clicking N and then typing in itable. Now the itable, what it is an information table. It just stores data, and it stores data on an X and Y axis, and it goes from a range of 128 data points on the x-axis and 128 data points on the y-axis. So it's like a coordinate-based system, which works great in building a sequencer. So here you see I'm drawing in data, and yep. So now what I want to do is I want to change the size and the range of the itable, because I wanted to go for 16 steps and have only 16 steps on the x-axis and only 3 inputs on the y-axis. So what I'm going to do is I'm going to go into the inspector for the itable. You do that by clicking on the itable and hitting Command plus I, and that opens up the table inspector. And here you can go and change the range to 3 and the size to 16. So now we have our 16-step sequencer. Now this row will hold all the kicks, this row will hold the snares, and this row will hold all the hi-hats. Now as you see, when something comes on the hi-hat pattern, it goes away from the snare and kick. So that's basically it. Now we need something that counts throughout the 16 steps and reports back at what step what input is put. So we can do that by bringing out a counter. So the same process, you hit N, you type counter, and since needs to go for 16 steps, we're going to type 0, 15, because the counter index is from 0, and so does the itable. The first input on the itable is 0, and it counts up to 15. So there you go. We have a counter. I'm just going to feed that in there, line that up. And we're going to bring this here. Now we need something to bang the counter at a specified rate to report back the values. So we're going to bring up Metro. Type Metro 500 and give it its activation flag. So now the Metro should be banging the counter. The counter should be counting from 0 to 15. You can check that by bringing up a message box, and we see that. And if you bring it here, it should be reporting back the values. Now, since we have a counter that's reporting back the values, we don't know exactly where each where the bar is, like where it's counting from. So we can solve that by bringing in a slider, and the slider can tell us where it's going to be. The slider is going to indicate and give us visual feedback as to where the counter is counting on the itable. So we can do that by going again in the inspector of the counter and change the knob shape to an indicator. And there you see, it is just an indicator now. We can take the background color and turn its opacity down. And go down here and change the range to 16. Now, if you bring this, resize it, and feed this the counter value to, you see, it's counting from 0 to 16. Sorry, 0 to 15. Bring this here, we have now visual feedback on what the command is doing. What we're also going to do is we're going to ignore the click for the slider, so that each time you click it, we are not selecting it. Cool. Once that's done, now all we need to do is that each time it gives us a 0, we need to tell it that, okay, when you get a 0, you need to send out a kick. Each time you get a snare, a 1, you need to send out a snare. And each time you get a 2, you need to hit the hi-hat. So we do that by a few if-then statements. So we bring in an if-then statement. So if $I1 is equal to 0, then bang. So each time it hits a 0, bang. We're going to build another one. Says each time it hits a 1, bang. And each time it hits a 2. So this is going to give us the kick, snare, and hat bangs. So we can check that by putting a bang over here. And you see, each time it hits the kick, it's gonna bang, bang. Cool. Now what we do is we need to make these give us notes. Now the way that you create a MIDI event or MIDI note in Max is you use the make note object. So you just bring out a make note object, and there you go. Now the make note object takes in the pitch, the velocity, and the duration of the note. So we're going to make 3 of these. Cool. One for the kick, one for the snare, and one for the hats. Now what we're going to do is, we need to tell the make note what note it needs to send out. So we can do that by bringing out a number box. We do that by hitting I, and we're going to change its properties. We're going to change its display format from numbers to MIDI C4. So then we can tell it exactly which note we wanted to send out. And put this 3. Now usually a kick in MIDI notation is a C1. A snare is usually D1, and the hat is usually F sharp. Usually. Cool. So this is gonna, each time it gets on the kick, it's gonna bang me at C1. That's 24. And so that's our pitch taken care of. Now what we need to put in is we need to put in the note velocity, I'm guessing. Yes, the note velocity. Now since note velocity goes from 0 to 127, we can bring in a number box and say that maximum 127, minimum 0. So that brings in a box from 0 to 127. There we go. Just space this out so that it's a little bit more neater. And do that here as well. So that is done. Now what we need to do is we need to give a duration number. So you're going to build another number box, and I think so the maximum duration of 200 milliseconds is way more than enough. So maximum 200 and a minimum of 20. So that's a good starting value. Let's connect that there. It's over here. It's over here. So now this will be giving us all the notes that we need. So if we go here and we take, see, it's giving us a pitch output, and it should give us a list over here of velocity. There you go. It gives the velocity on and off. So to reinstantiate this. Now we need these notes to go out into the max world. So we're gonna put in a note out which transmits MIDI note messages. All we need to do is we take the pitch output for each of them, put it in here, and then take the velocity output, put it all in here. I'm just gonna copy this patch filter. And now if we go back to live, there you go. We're seeing MIDI information for each of those notes. And you'll see them here too. For some reason it's sending it C0 instead of C1. That's weird. Let's put to C2. There you go. So this would be D2, D, F sharp, 2. There you go. So there we have it. That's the basic purpose of the sequencer. Now what we need to do is we need to make sure that it is synced to our transport, and we do that by we first do that by bringing in a plug sync object. What the plug sync object does is it reports back the transport of live. So if I hit play here, I can monitor the current bar count. There you go. We have 4 bars, 5 bars, and the 6th bar. And if I go over here and increase my tempo, let me see this more quicker. There you go. So now what we need to do is we need to, first what I'm going to do is I'm going to make something bang this counter and bang the counter at a constant rate. So for that, what I'm going to do is I'm going to bring in something called a phaser. Now, if you're familiar with what a phaser is basically a ramp that goes from 0 to 1. So if I go in the help section, I can go and find the tempo later one. Just steal this edge detect little abstraction because never learned how to make it, and it's right there. I don't need to. So what phases 16 and lock 1 does is that it syncs up lives. What do you say? It syncs up lives. Transport to the phaser. So phaser is basically a ramp that goes from 0 to 1, and what it does is it just reports back times at a constant interval. So it's a way more stable clock than Metro, because Metro can Metro is based on max messages, so sometimes it can get a little wonky and it may not work all the time, but this just works way better. So we're going to use this, and that's going to report. Okay. Slow this down. You see, it's working along with that. Just going to make sure this is. Command H. No, not Command H. That hides it. There's a way to auto-align, distribute, vertical, take, that equally distributes all the objects. Cool. So this is something that we can do to make sure that it runs at a constant rate. Now what we want to do is we want to make sure that we can change how fast the how fast the sequencer runs. Sorry, I'm just losing words. And for that, what you need to do is you just need to change the time interval of the phaser, and we can do that by building a menu box. So we just go live menu and go in here, and we can change its contents. So we can say 16N, 8N. Actually, we can do 32N, 16N, and I don't need to give commas. 16N, 8N, 4N, 2N. So those are our time values, and all we need to do is just tell that to phaser. So if we go 16N, it's going to be at 16 notes. 8N, it's going to be at 8 notes. So you can see. There you go. So that's taken care of. Now what we need to do is, that's all said and done, we need to make sure that each time we change, we need to make sure that these 16 notes of the sequencer are in line and in sync with the 16 notes in live transport, because if you stop or start this sequencer, it should stop or start this transport, and it should be synced to this bar, and that's where plug sync comes in. Now if you go in plug sync, you can see that it's going to give me a tempo out, but on the third last output it's going to give me the ticks out. So if I just see what that looks like, this is what it looks like. Just give me a constant output of ticks. That's the pulse. That's the pulse per quad auto note of the values of the transport. Now what I'm going to do is I'm going to do a little bit of math over here. I'm going to multiply that by a certain amount. So I'm going to bring that in here, and the amount that I'm going to multiply it by is going to be dependent on what value I send out from here. So let's say if it's a 16 note, then I need to multiply it by something, so that I need to multiply it by a certain value so that it always syncs up to be the same. Now how I figured this out was, what I did was I made a few if then statements. So if $I1 is equal to, let's see, 0, 2, and $N equal to 4, and this is 8, and so it's going to be 2. If it's 2, then it needs to be 8. If it's 3, it needs to be 16. If it's 4, it needs to be 32. I know this might seem weird for now, but just stay with me and you'll get why I'm doing this very soon. Cool. Now what we're going to do is we're going to take this, what we multiply by 1, and we're going to put something in the right one, the one that sets the right hand operand. So it always needs, and we're going to multiply this by something. So what we're going to do is I'm going to bring in a divide. Just going to keep it something to like initiate it, but that's going to change very soon. And we're going to bring in a trigger option. So what this is going to do is it's going to set my right hand and my left hand all grand and bring all these over here. So what this is going to do is the eye is going to pass whatever needs to come out, and that's going to be divided by 16. So if I go 16n, then what I'm going to get over here is 4. 32n, I'm going to get 8. I'm going to get 1. I'm going to get 0.5. So that's what this 1 has been multiplied by. Over here, this is what I get. If I go over here, this is what I get. This is what I get. This is what I get. This is all basically done so that I can sync it back. I'm sure there might be a better way to do this, but this is the one that I figured out. And then I'm going to modulo this by 16. What that basically means is that each time it reaches 16, it's going to give me a 0. So this is at 2n, this is at 16n. There you go. That's all it does. So if we do this, oh, let's see. Sure, we can do this too. Change it. And if I stop this, start it again, it's always going to be synced. You can check that by putting on the that's something that you can do. Or what we can also do is we can make a change. I typically don't like doing this because what it does is it's all relied on max messages then. And I kind of find that finicky to work at times. So basically what I do is I make sure that I then put another if then statement that says if $I1 is equal to 0, then 0. This basically does is each time this comes back to 0, it's going to send me a 0 out. And I'm just going to put that on the reset counter to number immediately. Because I just find keeping phaser to be a little bit more accurate timing wise than using this just a max message. I know it's just something that I've always done and I find being comfortable in doing that. It's just a personal thing. Cool. So now that we're all done with this, we just need to turn it into a presentation mode. So what we're going to do, I'm going to save this here, call it Drum. Cool. Now to close this, we go here, this is what we get. We can't really see what's happening and there's nothing to touch except maybe this. So what we can do is we're going to turn this into a presentation mode. For that, what you do is you have to basically select what things you want to be in the presentation mode and hit Command Shift P. And this it gets like this outline on that which says that okay, that's in presentation mode. So I'm going to turn this, and I'm going to take this, then the presentation mode. When you hit this, you see that's all that we get. And we can arrange this nicely. Take this whole thing. Arrange this nicely somewhere top left corner. If you want, you could put a panel, make it look all nice. Put this over here. This. And this. And this. Cool. And what we're also going to do is we're going to go in the inspector and the patching inspector. So we're just going to not select anything. Inspector, show patching inspector, and opening presentation. So as you see, those are out of the view. So we're just going to shrink this a little bit. Make sure that this comes in. And if we do this and just hit go to, I believe it's view, yeah, and set device width. So if we save it and close it, that's all we're going to see now. Now you might notice that we aren't getting any notes. That's because this is set back to C0, C minus 1, all that, and sharp 2, and we need to bring up. Now each time I close and reopen this, I don't want to put that in again. So what we're going to do is we're going to initialize this. And for initialization, what you need is just a couple of things. So I want to say that each time I open or load this, I want this to be set to a certain amount of values, and I want this to be set to 16 node. So what we're going to do is we're going to use a live.this device, which was basically what it does. Each time you load the device, it's just going to send a bang. See, it says outputs a bang when the patcher device is loaded. So what we're going to do is what do you call that? Okay, I'm just going to give it a message box that says what. Right output, and it says that. There you go. Double click on that, and just sent out 1, and that set that to 16. And what else we're going to do is, let me see if we have a live dot number box. Oh yeah, there you go. You know what? I'm going to substitute this for this. Because it's just best to use live live objects for making max live devices, because they are parameterized. So each time you close and open them, they are gonna save their settings. I'm gonna do that for all of these guys. Should have started off with that. I made a mistake up there. That's fine. We live and we learn. Let's see. Let's make sure this is all lined up. And I'm sure there's a way to even change a live.numbox so that it gives not MIDI. Unit star, there you go. MIDI. Sweet. Just gonna delete these. Just put it in live.numbox. Cool. Now how to parameterize enable these. What I'm gonna do is I'm gonna bring in a message box that tells me which notes I want to initialize at. So that's C2, D2, and F sharp 2. and I'm going to give this a light dot this device. So that's going to bang if it opens. And what I'm going to do is I'm going to do an unpack I. So that's going to unpack that list, and I'm going to send this here, this here, and this here. So let's test it out. It doesn't want to change. Because why? It's giving me 0 out. So 24, 36, and that's weird. Give me floating point for some reason. That's all. Okay. Let's see. What's C2? C2 should be 48. D2 should be 48. Should be 49. Yeah, 47, 49, and 53. 47, 49, 53. If I do that and bang this, sorry, it needs to be 48, 48, 50, 54. That should give me the right values. Yeah, there you go. I'm going to bring out another light this device with an unpack and tell it what the velocities need to be. It's going to bring it all at 127. There you go. 36. 50 minus 12 is and it should be 42. Pressing. Yeah. Cool. Now we're going to put these in presentation mode. Go into presentation mode. Make sure you bring these up. Here. And save it. And close it. There you go. That's a basic sequencer. You can go and change things. Cool. That's it.